We've been working with ratios, and we're going to look at how we can also use them in tables and graphs. A ratio table is a way that we can compare quantities. So we're going to look at different situations where we're going to have those equivalent ratios, and we can compare those using the skills that we've already done. So we have here where it says that Todd earns $3 for every 5 chores he completes on his chore chart. We're going to find the equivalent ratios using this table. So we know that when he does 5 chores, he earns $3. So if we continue with that pattern, then we can say when he does 10 chores, he's going to earn $6. When he does 15 chores, he's going to earn $9. 20 chores would earn $12, and 25 chores would earn him $15. We could take every single one of these situations and it would simplify down to a 5-to-3 ratio. So all of these are equivalent because they do simplify down to 5-to-3. So our number of chores and the amount of money earned are related using a 5-to-3 ratio. If we look at the chore column, so just at this column here, and we think about how those are related, those are increasing by 5. Each time we increase by 5 as we move down that column. If we look at the values in the money column, which is right here, we can look and see how those are related, and we can see that they increase by 3 as we move down that column. And as we look at this ratio column, we can see that simply they are equivalent. All of those ratios are the same, so all of our ratios in our chore chart are the same as well. So if you look at the back of a box of pancakes, you will see a table that shows how many pancakes you want to make, how much mix, and how much water you want to use. Some mixes will say milk and eggs. It just depends on what mix you buy. But you'll see that those ratios remain the same no matter how many pancakes you make. So here we've got this person that is going to make pancakes, and we need to look at the ratio. So we have a 1 to 1.5 ratio for our first line on our table. So this is kind of like our base ratio where we're starting at. If we were to take that and double that recipe, just like you did before, double that recipe, we would have 2 cups of pancake mix to 3 cups of water. That's still going to simplify down to a 1 to 1.5 ratio because all we did was multiply by 2 as we moved down the table. Well, this next time, if I needed to use 3 cups of mix, I would use 4.5 cups of water. All I'm doing here is I'm multiplying that ratio by 3. I'm multiplying both sides by 3, so my base ratio stays the same. So that means if we use 4 cups of mix and 6 cups of water, again, it's going to stay the same. So it's a 1 to 1.5 ratio. So now we've got to find out how many cups of pancake mix we'll need if we're going to use 15 cups of water. So we're going to set up those proportions like we have been working with. First, we'll have our labeling ratio, which is going to be our mix to our water. We're going to use this base ratio here. 1 cup of mix uses 1.5 cup of water. So we need to know how much for 15 cups. So I'm going to look for this relationship from 1.5 to 15. That means I'm going to multiply by 10. So 1.5 times 10 is 15. So that means I have to multiply my numerator by 10. 1 times 10 is 10. So I'm going to need 10 cups of water. What we're going to do here is I'm going to help you fill in the tables, and then I'm going to have you pause the video and work out the problems. It is imperative that you are setting up proportions the correct way. I realize some of you may have another way that you would like to solve these, but I need for you to practice the way that I'm showing you now while the numbers are easy, because they will be getting very hard very quickly. So if we've got a recipe for cookies that calls 3 eggs for every 2 dozen cookies, we need to fill in this table. We're going to start with that base ratio, 3 eggs, 2 dozen cookies. So now we're going to double it, and that would be 6 eggs, 4 cookies. We're going to triple it, 9 eggs, 6 cookies. And then we will quadruple it. So it'll be 12 eggs is going to give us 8 dozen cookies. Over here at number 4, where it says a developer earns $6 for every 21 apps downloaded, we're going to complete the table the same way. So we're going to start off 21 apps would be $6. So 42 apps would be $12. So then we're going to move up again, and it's going to be 63 apps would be $18. And then 84 apps is going to be $24. I want you to pause the video here and then come back and check your work. All right, check your work. Make sure that your work is shown the correct way by setting up proportions, and make sure that you have the correct answers. This one is especially important. It's asking, remember, these are dozen cookies. Those are dozens. So it asks how many cookies can be made. Your response needs to be either 8 dozen or 96 cookies. Okay, one or the other. You cannot just have 8 as your answer because you're making a lot more than 8 cookies. Sometimes we can also represent ratios on a graph. And when you do, you can look at your x-axis. You're going to have one value there, and your y-axis is going to be another value. In this case, we're talking about the number of miles that are traveled by a family on a road trip per hour. So you can see our x-axis has the number of hours, and our y-axis has the miles that they traveled. So if we look at this, we can start at the 1 hour and look and see where it is connected at the 50-mile mark. So what that means is that our ratio of hours to miles is a 1 to 50 ratio. 1 hour, they're driving 50 miles. So then we've got to figure out how many miles that they could travel in 12 hours. So we're going to set up that proportion. It's going to be hours to miles. So 1 hour is 50 miles, so we've got to figure out for 12 hours. So we are going to find that relationship from 1 to 12 means we're multiplying by 12. So we have to multiply 50 by 12, and that's going to give us 600. So they'd be able to travel 600 miles. How many hours will it take the Moore family to travel 700 miles? We're just using the same situation. Hours, miles, 1 to 50, and we're going 700 miles. Okay, so we're going to multiply 1 times 700 in order, oops, I did something wrong here. What did I do? We're not traveling 700 hours, we're traveling 700 miles. Got to be careful. That's why those labeling ratios help, because even I can make a mistake and get things mixed matched. So we want to be careful. So 50 times what number is going to be 700? Well, it's times 14. So then 1 times 14 is 14. So we know it's going to take them a total of 14 hours. So let's say you had this ordered pair, 6 and 300. 6, remember, is our x. Y is our 300 here. So x is hours. Y is miles. So this is telling us that in 6 hours, they would travel 300 miles.